Wireless spectrum is always at a premium. If you've ever tried to connect to Wi-Fi in a crowded airport or stadium, you know the pain that comes from crowded spectrum use. That's why the industry continues to tinker with ways to get the most out of available spectrum. The latest example, Qualcomm's Fast Connect 7900 chip, which the company unveiled Monday at Mobile World Congress in Barcelona. Qualcomm touts the Fast Connect 7900 as a provider of AI-enhanced Wi-Fi 7, which the company views as an opportunity to create more reliable wireless connections. The chip will also better integrate the disparate technologies of Wi-Fi, Bluetooth, and ultra-wideband for consumer applications. In addition, the chip can support two connections to the same device over the same spectrum band. The Fast Connect 7900 comes as the wireless industry renews its focus on reliability with Wi-Fi 7, the wireless tech standard's latest generation. The emphasis comes in addition improving throughput and decreasing latency, something to which every Wi-Fi generation contributes. Wi-Fi is a range of wireless networking protocols based on the IEEE 802.11 set of standards. The IEEE is IEEE Spectrum's parent organization. AI-enhanced Wi-Fi. Wi-Fi is a bit like the Wild West, says Javier Del Prado, Vice President for Mobile Connectivity at Qualcomm. It's all sorts of devices out there, congestion, devices that come in and go off, access points that do this, access points that do that. It's very difficult to guarantee service. Del Prado says that AI is the perfect tool to change that. Key to the Fast Connect 7900's capabilities is the chip's ability to detect what applications are in use by the device. Different applications use Wi-Fi differently. For example, streaming a video may require more data throughput, while a voice chat needs to prioritize low latency. After the chip has determined what applications are in use, it can optimize power and latency on a case-by-case basis. Using AI to manage wireless spectrum connections isn't a new problem or solution, but Qualcomm's chip benefits from running everything on device. It has to run on the device to be effective, says Del Prado. We need to make decisions at the microsecond level. Put another way, using the Wi-Fi connection itself to transmit the information about how to adjust the Wi-Fi connection would defeat the purpose of AI management in the first place. By the time the chip receives the information, it'd be way out of date. Also important, the chip doesn't suck power. In fact, it saves power overall. These are fairly simple models, says Del Prado. It's not a 5 billion parameter AI. It's a much smaller model. The key performance indicators are the speed and the accuracy. Del Prado says that the chip's power consumption is negligible. In fact, because of its ability to optimize power, depending on what applications are running, the chip saves its device up to 30% in power consumption. Wi-Fi and Bluetooth and ultra-wideband, all in one. Outside of cellular, Wi-Fi is the most common way our phones connect with the world. But it's not the only tech. Bluetooth is used for things like wireless earbuds and ultra-wideband, UWB. Also see some use for applications like item tracking, think Apple's AirPods, and locking and unlocking cars remotely. All three technologies rely heavily on proximity and distance ranging to maintain wireless connections. There are all these use cases that use proximity and that use different technologies, says Del Prado. Different technologies bring different benefits. There's not always a single technology that fits all use cases, but that creates complexity. Qualcomm's Fast Connect 7900, Del Prado says, will hide that complexity. We make it technology agnostic for the consumer. Sharing spectrum bands. One final trick the Fast Connect 7900 offers is an ability to host two Wi-Fi connections on the same band of spectrum. Here, the chip is building on previous Fast Connect generations. We already introduced what we call hybrid simultaneous. This is the capability of doing multiple channels simultaneously on the 5 and 6 GHz bands, says Del Prado. New to the 7900 is audio over Wi-Fi, says Del Prado. Qualcomm is calling it XBEN, and it's a separate channel for audio only in those 5 GHz and 6 GHz bands. This matters because those spectrum bands can deliver a much higher audio quality to the device compared to, say, Bluetooth, which operates in the 2.4 GHz band. By carving out a separate channel just for audio, says Del Prado, the The 7900 chip can provide that much better audio quality without it succumbing to the strain that typically emerges when multiple connections demand the same wireless signal. That's something that cannot be done with Bluetooth today because it's bandwidth limited, says Del Prado. Qualcomm is already sampling the Fast Connect 7900 to its customers, that is, manufacturers of phones and similar devices. Del Prado estimates that the first products with the chip will hit the market in the second half of the year. When the new round of premium Android phones hits the market later this year, those should support this functionality.
With AI-enhanced Wi-Fi and chips like Qualcomm's Fast Connect 7900 now capable of making real-time decisions about our wireless connections, will we eventually rely so heavily on AI to manage spectrum that human understanding and control of our own networks becomes obsolete?
The article doesn't explicitly address the long-term implications of AI managing Wi-Fi spectrum for human control, but it offers some clues. Focus on optimization, not control. The article highlights the Fast Connect 7900's ability to optimize power and latency based on application usage. This suggests a focus on improving efficiency and performance within existing parameters, rather than taking complete control of network decisions. Simple AI models. The article mentions simple models used for AI management and emphasizes speed and accuracy as key indicators. This implies that the AI involved is task-specific and not geared towards autonomous network control. Human expertise still crucial. The development of these AI-enhanced chips still relies heavily on human engineering and understanding of wireless technology. Qualcomm engineers designed the chip and its features, highlighting the ongoing need for human expertise in the field. Therefore, based on the information provided, it's premature to conclude that human understanding and control of networks will become obsolete. While AI is playing an increasingly significant role in optimizing network performance, it's likely to remain a tool used by humans to manage complex systems, rather than completely replacing human oversight. However, the article does raise interesting questions about the future of AI and network management. As AI models become more sophisticated, it's possible that their role could expand beyond optimization to encompass more autonomous decision-making. This could potentially lead to scenarios where human understanding of network operations becomes less critical for day-to-day management. Ultimately, the balance between AI assistance and human control will likely depend on factors like the pace of AI development, industry regulations, and societal acceptance of autonomous network management.
As AI-driven chips like Qualcomm's Fast Connect 7900 continue optimizing wireless connections in real time without human input, could we eventually reach a point where these technologies prioritize machine-to-machine communication so strongly that human users experience degraded network performance? If AI starts determining what's best for the whole system, might human needs take a backseat in certain scenarios?
It's a valid concern. While the article focuses on the benefits of AI-driven optimization for users, your question highlights a potential risk of prioritizing the system over individual human needs. Here's a breakdown of why this is a complex issue and the factors to consider. The potential for conflict. Resource allocation. AI prioritizing the whole system could mean favoring applications with high bandwidth demands, e.g., machine-to-machine communication, industrial automation, over those prioritizing low latency for human interaction, e.g., video conferencing, online gaming. Definition of best: best for the system might mean maximizing overall throughput or minimizing energy consumption. However, this could come at the cost of increased latency or reduced quality for certain user-dependent tasks. Lack of contextual awareness. Current AI models, while advanced, might not fully grasp the nuances of human needs in diverse situations. A slight delay in a video call might be insignificant to the system but incredibly frustrating for the humans involved. Mitigating the risks. Ethical considerations in AI development. As AI plays a larger role in network management, developers must prioritize ethical considerations, ensuring human needs aren't unintentionally sidelined. Human oversight and control. While AI can handle real-time optimization, maintaining human oversight and the ability to override AI decisions in critical situations will be crucial. Transparency and explainability. Understanding how AI makes decisions about network traffic is important. Transparent and explainable AI allows for auditing and adjustments if biases against human-centric needs emerge. The bottom line, it's possible that without careful consideration, AI-driven network optimization could unintentionally prioritize machine-to-machine communication at the expense of human users. However, this isn't a foregone conclusion. By addressing the ethical considerations, maintaining human oversight, and building transparency into AI systems, we can work towards a future where AI-powered networks enhance human experiences, not detract from them.